your final exam will not look identical to this. It won't be that, but it will be something similar. And the idea is that it's cumulative. The idea that it's comprehensive. So if you guys have an idea of where to start, if you guys have a particular kind of question that you're like, you know what, I'm not too comfortable with this, we can start with that. With anybody, any suggestions you may have. If not, I'll just start with the first one, and we can move on downward. So up to you guys. So if you have any kind of question that takes your takes your breath away, and you're like, wait a minute, what in the world is that? If not, then we can just go with number one. So nothing interests you, nothing piques your interest, that's okay. So the answer to his question, to Nargis' question is yes, we will be on Zoom for the final. Everything will be done on the final through Zoom. And by the time we hit 1 p.m. May 24th, no more Zoom. No problem. Yes, everything will be on Zoom. So again, we have Wednesday today, we got next Monday, and then we got the Monday after that, and that's it. No more Zoom. We're done for Zoom for this semester for Math 115. Okay, guys, so this is review, today's review, Monday's review, everything we've done. At least we try to cover everything we've done. So this is one final exam that's comprehensive and covers most of the stuff that we've done. Okay, so start with number one. Number one, what do we have? Length, yeah, length means, so, okay, so let's do number one. So points -3, 1, and 2, -3. What I'm going to do is I'm going to draw, so this is number one, okay? I'm going to draw the graph. I'm also going to give you guys a review sheet for all the topics after exam number 2. So the idea is, what I would suggest is, you know, we're going to go over this, and then on Monday I'm going to also have a review session and probably go over review sheet number 3. So I'm going to post review sheet number 3 soon. And the idea is that we've done review sheet number 1, review sheet number 2. So those are the topics that are covered in exam number 1, exam number 2. Now the final exam is everything from exam number 1 and exam number 2 and everything after exam number 2. And that's what review sheet number 3 will cover, everything after exam number 2. And then you have that to study. So review sheets 1, 2, and 3. You have your past exams. I will also upload for all the past exams and all the past quizzes. I will also upload solutions to the past exams. So exam number 1, exam number 2, you'll have the solutions to it, and you'll see how to fully solve a problem. And that's the way you can approach your preparation. Okay. So the XY plane, right? And then I have 2 points. I have -3, 1. So -3, 1. And then that's P, and then I have Q, 2, -3. This is P, this is Q, okay? And then what they say is this is a segment. Line segment just means, hey, connect the dots. Boom. This is my line segment. And I want to know the first thing, right? Part A is find the midpoint. Midpoint of PQ. So it's the line segment PQ, and I got -3, 1, and I got 2, -3. Now the question is, what's the midpoint formula? So this is where you have to remember the midpoint formula. What is the midpoint formula? It's the average of the x values and the average of the y values. So what's the midpoint? Well, what's x1? What's x2? It's -3 plus 2 over 2, comma, 1 plus -3 over 2. -3 plus 2 is -1 over 2. 1 plus -3 is -2 over 2, which is -1/2, comma, -1. That's my midpoint. I'm done. That's my midpoint. So -1, comma, -1/2, comma, -1. I'm right here. Boom. This is my midpoint. Midpoint means I'm halfway between the two endpoints. That's what the midpoint is. I'm halfway between. So that's part A. How about part B? Part B is asking for the length, right? I want the length of PQ, and Jalen, you correctly interpret it as distance. The length of PQ is the same thing as saying the distance. The distance between P and Q. Isn't that the length? The distance between 2 points, isn't that the length of a straight line connecting those 2 points? So that's exactly right. So I need to remember now. So these are all things you have to remember. Right? Hold on. I need to remember the midpoint formula. I also need to know the distance formula. What's the distance formula? X1 minus x2 squared plus y2 minus y1 squared. The ordering really doesn't matter, but just to keep it consistent, I do 1 minus y2. That's my distance formula. So this is another plug-in question. Square root, what's the square root of what? -3 plus 2 squared plus 1 minus 3 squared. This is -1 squared plus -2 squared. This is 1 plus 4 square root. This equals rad 5. So the length is rad 5. Done. That's the length. What else do we want? That's A, B, C. Write an equation of a line perpendicular to PQ that passes through its midpoint. Okay, so let's break it down. I want to find a line that's perpendicular to PQ that goes through the point, the midpoint. So what I want is this. This is what I want. I want a line that's perpendicular to the line PQ. I want a line that's perpendicular and that goes through the point, the midpoint, which is what? -1/2, comma, -1. I want to go through that point. So to find the equation of the line, what do I need? You guys remember? I need two things. I need the slope, I need the y-intercept. So the first thing is the slope. What is the slope? I want this equation of a line that's perpendicular. Remember, perpendicular. Now you have to remember, what does a perpendicular line mean? What do we know about slopes of perpendicular lines? To go all the way back to the beginning of time. Slope is negative reciprocal. Very good. Very good, Jalen. So we want negative reciprocal, right? I want this to be a negative reciprocal. For negative reciprocal of what? Of slope of PQ. So I have to find PQ. What's the slope of PQ? What's the slope of PQ? What is the slope formula? y2 minus y1 over x2 minus x1. What's y2? Negative 3. What's y1? Negative minus 1. What's x2? 2. What's x1? Minus negative 3. So what's going to be the slope? Negative 3 minus 1 is negative 4. 2 minus negative 3 is 2 plus 3, which is 5. My slope is negative 4/5. But that's of this line. I want this line. And you just said it has to be negative reciprocal. So what's the negative reciprocal of negative 4/5? What's the negative reciprocal of negative 4/5? Anyone, anybody out there? It's the negative reciprocal. So remember, negative means you change the sign. So if it's negative in the beginning, it's not going to be negative after you take the negative of a negative, which is a positive. And the reciprocal means flip. So that's right, Sierra. So the slope is going to be slope of perpendicular line. So I'm going to write perp line. The slope of the perp line is the negative reciprocal, which is 5/4. So I got the slope. The slope of the perpendicular line is 5/4. Sorry, my handwriting is a little bit messy with that. Okay, now I had the slope. And what else do I need? I need a point. What is the point? It's the midpoint. What is the midpoint? Negative 1/2, comma, negative 1. How do I find the equation of a line if I know the slope and the point? Do you guys remember what formula I should use?
You use the point slope form. Y minus y1 equal x, m into x minus x1.
Very good, very good. So point slope form, that's right. The point slope form is y minus y1 equals m times x minus x1. I have the point, negative 1/2, comma 1, negative 1, and I have the slope, 5/4. So all I do is plug in y minus negative 1 equals 5/4 x minus negative 1/2. Y plus 2 equals 5/4 x plus 1/2. And this is done. This is the point slope form. This is called the point slope form of a line. Now the question I'm going to also might ask is, what if I want to write it in slope-intercept form? What if I want to do that?
Wait, do that by solving for y?
I have to solve for the y. That's right. So I have to do a little bit more algebra, right? So let me do that. So y plus 2, that equals 5/4 x plus 1/2. I can distribute now. And this becomes 5/4 x plus 5/8 because 5/4 times 1/2 is 5/8. Y plus 2. And then subtract by 2, and I get that y equals 5/4 x plus 5/8 minus 2. What is that? That's 5/8 minus 16 over 8, which is negative 11 over 8. So this becomes negative 11 over 8. So this here is equivalent to this, but this is the slope intercept form. They're the same. The same length. One is the point slope form, the other one is in slope intercept form. What did I even, that looks like a B. So point slope form of a line. Okay, so far so good. Again, review. All this is review. All of this is something you've seen somewhere or another. You've seen midpoint before. You've seen distance before. You've talked about you find the equations of the lines before. This is all done before. Nothing new. Nothing new. Okay. Next, last thing. Write an equation of a circle. Circle came up again. Wow, we just did circles. Write an equation of a circle whose center is the midpoint and whose diameter is PQ. Oh. Oh. So I want to find, hold on. This is part D, right? I want to find the circle. So not the circle. I want to find the equation of the circle. Equation of circle with the following conditions. The first is that the center is the what? The center is the midpoint. So the center is midpoint of PQ. But what is the midpoint of PQ? Isn't it negative half comma 1? Negative 1. We already know what the midpoint is. And the second thing is that the diameter is equal to what? PQ. Now, if you recall, a circle has a radius, and if you double the radius, you get what's called the diameter. So the diameter, if I were to draw a circle, this is what the circle look like. You see that? That would be the circle, and this would be the center. Now they're saying that the diameter is this. I found the diameter already. The distance between the 2 points is rad 5. This is the diameter, rad 5. So if the diameter is rad 5, the radius is half the diameter. So this means that the radius is 1/2 diameter, but the diameter we already know from part A is that it's rad 5. This is from part A or part B. The distance, right? So I know that my R value is rad 5/2. So these are the two crucial points of pieces of information. I got the center and I got the radius. And now what you have to recall is that the standard equation of a circle, what is the standard equation of a circle? What's the standard equation of a circle? X minus h squared plus y minus k squared equals r squared. That is something you have to know. Remember, what does h and k represent? It represents the x and y coordinates respectively of the midpoint. So all I have to do now is plug in. So I get x minus negative 1/2 parentheses squared plus y minus negative 1 squared equals rad 5/2 squared. And then I can make this a little bit nicer because I got x minus 1/2, which is x plus 1/2 squared plus y plus 1 squared. Rad 5/2 squared is rad 5 squared, which is 5, and 2 squared is 4. So this would be my equation. This would be the equation of the circle. Any questions on number 1? Any questions at all for parts A, B, C, or D? So midpoint formula, you must know. Distance formula, you must know. Slope of a line, you must know. Slope intercept form, you must know. Point slope form, you must know. Standard equation of a line, of a circle. You must know. Okay. Any questions for number one? You got a different answer to part B? What'd you get? What'd you get for part B? I may have done something wrong then. Is it, oh, hold on, 1 minus, oh, I think I may have mistaken something, right? So x1 is -3. Oh, that, yeah, you're right. Pardon me for that. So this is x1 is -3 minus 2. That's my mistake, guys. This should be a -2. So if you do that, this should be what? -5 squared. And then y1, let me just make sure that's okay. Y minus -3. Pardon me for that. Y minus -3. That becomes what? +4, right? Is that right? Yes. That's a 4, and then that's a 5. So then this is not the answer. This is 25 plus 16, which is 41. Yeah. So be very mindful of these negative signs. I just assume that to be a negative. So you have to be careful, okay? When you plug in these values, make sure you put the parentheses around them so you know that you're taking minus of a negative number, which means you're adding them. So that's going to change our answer for this one here because the diameter is rad 41, not rad 5. So this is rad 41. This should be rad 41. And then this should be rad 41. So then finally you should get 41. So there we go. Thank you, Meg. Thank you. Thank you for double checking. Always double check what I do. Always. That's why I ask so many questions. Like, hey guys, what about this? And then what about that? Double check all the time. So thank you. Any other thing? Any comment? Any other comments about number one? So number one packs a punch because you cover a lot of ground in number one. A lot. You go from the beginning of the semester, which is midpoint, distance, all that, to the end of the semester, which circles just pops up at the end. So there we go. That's number one. Good problem. I like that problem. Covers a lot. Okay, good. Nothing else? That's number one. Next. Number two. What does number two ask about? It's all about factoring, factoring, factoring. Let's factor. You guys are experts at factoring, right? So number two. So I want to factor completely a whole bunch of stuff. I have 3 expressions that I want to factor completely. So what's the first one say? Let me just... The first one is 12 a to the fourth b minus 27 a squared b cubed. Okay, so I want to factor this. What should I do first?
Can you factor using GCF?
Yes, I want to factor using GCF first. And what is my GCF? What's going to be my GCF for 12a to the fourth b, 27a squared b cubed? So between 12 and 27, what is the greatest common factor?
3a squared b.
That's right. 3a squared, and then you're missing one more thing.
B.
B. That's right. So this is my GCF. Okay, I've established that. Now I need to factor the GCF out of each term. When I do that, I get what? I get 4a squared, right? Minus 9b squared. Do you see that? So when I factored out the 3a squared b out of each term, I'm left with 4a squared minus 9b squared. Am I done factoring completely? No. What is 4a squared minus 9b squared? What is that? What is this? Perfect square. This is a difference of perfect squares. That's right. Difference of perfect squares. And we all know how to factor such an expression, don't we? It becomes like two parentheses. And what is the factorization of 4a squared minus 9b squared become? It will be what?
2a square minus 3b square.
So it's 2a plus 3b, 2a minus 3b, right? That's the difference of perfect squares. Don't forget, this is what? A squared minus b squared equals a minus b, a plus b. And so this is my final factorization. I can't factor any further. That's it. Okay? Any questions about factoring the expression in part A? No questions? Okay. Part B, 10 x squared minus 25 x minus 60. This is a trinomial. How can I factor this? What should I do first? What could I do? Well, what's the first thing we always try to figure out? Is there a GCF? That's the first thing. Is there a GCF among these three terms? Is there anything in common between 10, 25, and 60? 5. Thank you, Jalen. Yes, 5. So let me factor out this 5. Hold on one second. There we go. 5. This becomes 2x squared minus 5x minus 15. Not 15. What am I talking about? 12. So I factored out the GCF. Okay. But what's the problem? I still have 2x squared minus 5x minus 12. Can I factor this? How do I factor this? What method am I going to apply here? AC method, thank you. The AC method, what does the AC method indicate? 2, negative 12. When you multiply it, what do you get? Negative 24. What two numbers multiply to negative 24, but when you add them up, give you negative 5? What two numbers? What two factors of 24 differ by 5? So we got 2 and 12, that differs by 10. You got 4 and 6, that differs by 2. So what are the two other numbers that multiply to 24 being negative, and when you add them, give me negative 5? What do you guys think? Factors 24. Shouldn't be too bad. I just told you the ones that aren't good. 2 and 12 don't no good. 4 and 6 no good. There's one more. One more pair.
Positive 3 and negative 4.
Close. Positive 3, yes. So I'm gonna put that down, but not negative 4. 3 times negative 4 is 12. Negative 12. But 3 times negative 8, that's right. Negative 8, negative 8x minus 12, that's right. Pardon me. So then, once we have that set up, we factor by grouping. Remember this? So we factor the first group. What do we factor from the first group? An x. So we get 2x plus 3. What do we factor from the second group? We can only factor a 4. We get what? 2x plus 3. What do you notice again? 2x plus 3, 2x plus 3. You can factor that out. And you're left with what? 2x plus 3 factored out. And I'm left with x minus 4. And this is the final answer. So that's A and that's B. Okay? And then last one, 5PQ plus 15PR minus Q minus 3R. What we do here is when we have 4 terms, right? We factor by grouping. What can we factor from the first group? 5PQ plus 15PR. What's the GCF of this first group?
5p.
5p, that's right. So I can take out a 5p and I'm left with what? Q plus 3r, right? That's good. And then what can I factor from the second group? Negative Q minus 3r. What does that factor into? What's the only thing that can factor out? So this term here. That's right, Sierra. Very good. Negative 1. So when I factor out the negative 1, I change everything to Q plus 3r. What happens here? The Q plus 3r factors out. And I'm left with Q plus 3r parentheses 5p minus 1. And that is the factorization. That is the factorization of the expression for C. So that's number 2, guys. Number 2 is factor completely. That's what number 2 is. Okay. Any questions about factoring? Going once, going twice, sold. So number 3. Let's look at number 3. Number 3 is solving a system of linear equations. Look what we got. We got the first equation is 2x minus 5y equals negative 16. And the second equation is 3x plus 2y equals negative 5. And the question is, how do you solve? How do you solve this equation? How do you solve a system of equations? What do we have to do? We can use either graphing method, substitution method, or the more appropriate method in this case would be the elimination method. So you have to remember those methods. So I'm going to do it by elimination. So by the elimination method, I have to choose one of the x or the y's to cancel out, to eliminate. So which ones should I eliminate? Should I eliminate the x or the y's? It doesn't really matter at the end, but you can have a preference, and sometimes eliminating one variable is easier than eliminating the other one. So in this case, which one is easier to eliminate, the x's or the y's? Which is easier to find the LCM for, 2 and 3 or 5 and 2? It really doesn't matter, but so what should we eliminate? Eliminate what? Eliminate which variable?
The x.
No preference.
The x.
X. Okay. So I want to eliminate the x. So if I eliminate the x, I have to look at the 2 and the 3. And then I have to ask myself, what's the LCM of 2 and 3? 6. So I want to make both of them 6. How do I make the 2 into a 6, and how do I make a 3 into a 6? And on top of that, I need to make them opposite sign. So I want one to be 6 and the other one to be -6. Which one is positive, which one's negative? Doesn't matter, as long as one of them is positive and the other one is negative. So why don't we do this? Why don't we multiply the top by 3 and multiply the bottom by -2? Now, when you multiply, you have to multiply everything in the equation by the same number, not just one number. So now let's look at this new set of equations. Now this would be what? 6x minus 15y equals -48, right? So that's going to be my first equation now, because I multiplied the 3 to everything inside the first equation. And now when I do the same thing for the second equation, what do I get? I get -6x minus 4y equals +10. And then what do I do? Elimination method is also known as the, AKA the addition method, right? And the addition method means I just have to add. When I add this, what happens? The 6x's are swiped away, canceled out. And what I'm left with is -16y equals what? -38. Pardon me, what am I talking about? This is 19. -15, -4 is -19. And now I want to find what y is. So what must I do? Divide by -19. And so what does y equal? What's -38 divided by -19? 2. So I got that my y value equals 2. Awesome. So y equals 2, but now I want to find x. So how do I find the x value once I find the y value?
You do that by substituting the y value in the equation.
Correct. So then you take y and you substitute. So substitute y equals 2 into either equation to solve for x. Now, which equation do I use? It doesn't matter as long as you use one of them. Let me use equation 2. So let's use equation 2. Why use equation 2? Because it's just smaller numbers. It's easier. So we got 3x plus 2 times 2 minus 5. 3x plus 4 equals -5. Subtract the 4. I get 3x equals -9. Divide the 3. And I get that x equals -3. So I've solved the solution. I've solved the equation. And what's the solution? The solution is the following. The solution is -3, comma 2. That is my solution. -3, comma 2. So we had to recall how to solve the new equations by the elimination method, or also known as the addition method. And it's a very step-by-step procedure, and it will get you the right answer if you do the steps in order and correctly. All right, so 1, 2, and 3 we're good. So we've done lines, equation, we've done lines, distance, midpoint, circles, factoring, and we've done now linear equations. Now we're going on to some more stuff here in number 4. And in number 4, there's a lot of simplification we had to do. So we're simplifying a lot of different kinds of expressions. So simplifying expressions. That's what number 4 is all about. Now let's look at part A. Part A, look what we have. We got 1 minus 3 over x all over 1 minus 2 over x minus 3 over x squared. Now, what is this an example of? Example of what? What kind of expression is it? It's an example of when you have a fraction within a fraction, they're called what kind of fractions? It starts with a C. So there's a lot to review, isn't there? This is an example of what's called a complex, also known as a compound fraction. Whenever you have fractions within fractions, you have a fraction numerator, fraction denominator, it's called a compound, or it's called a complex fraction. And then what's the idea? I want to find the LCD. Remember, this is where the LCD is very prevalent. So what is the LCD among all the variables? I mean, the denominators. So I got x, I got x, I got x squared. The least common denominator is x squared. Once I know that it's x squared, what do? I multiply the top and the bottom by x squared. When I multiply a fraction with a fraction, I multiply numerators with numerators, denominators with denominators. So that means I have to distribute the x to everything inside. When I do that, I get x squared minus 3 over x multiplied by, I'm just going to write it in pink for now. And then, of course, 1 times x squared is just x squared. And then I get minus 2 over x multiplied by x squared minus 3 over x squared multiplied by x squared. Now, what happens when I multiply this? Cancels with one of them, cancels with one of them, cancels completely out. Now, what do we get in numerator? We get x squared minus 3. Sorry, minus 3x. This is all over x squared minus 2x minus 3. Now what have I accomplished? I've taken a complex fraction, I've got cleared out the denominators, and now I have a single fraction. Now, what could I do with the numerator and denominator in this fraction? What do I notice about the numerator? What can I do with the numerator? And remember, I want to simplify. Take out the x. I can factor out the x. So x is x minus 3 in the numerator. And how about the denominator? What can I do with the denominator? What is the denominator?
Factor it.
Yeah, factor. Remember, we want to factor simplify. What can we factor? X squared minus 2x minus 3. What does that factor into?
Is it x minus 3, x plus 1?
X minus 3, x plus 1. Perfect. And then x minus 3, what happens? See ya later. And this becomes what? X over x plus 1. And here we go. That's all we have. That's the factorization. Please do not cancel the x's. You can't cancel them because x is being added by 1, and this, in a sense, is in parentheses. So you do parentheses first, then you divide. So you can't divide before you add, before you do parentheses. So you cannot just cancel this out. You can't. I just want to make that clear. I've seen other people still do that mistake. When you simplify, you can't simplify in that manner. You can't. Okay, so that's part A. How about part B? What does part B say? The square root of 7x minus 3, I'm squaring that. And then I'm doing subtracting the square root of 7x minus 3, and I'm squaring that. So these are two different expressions. I'm squaring them, but two different expressions. So the easier one to do is this one. What happens when I take the square root and I square a square root? What happens with the square root? In this example, in this instance here.
We get rid of the square root since there is a square.
Correct. So that cancels out. But just be careful, okay? When you cancel it out, but you don't get rid of the parentheses. Because when you cancel this out, you're left with what? 7x minus 3, but the whole time you're subtracting whatever that is. So whatever this is, I'm subtracting from it. So I'm going to leave that negative out there. Now, for this one, I'm going to take a little bit more time with this one here. I'm going to do 7x minus 3 squared. What do I do here? What's the difference here? The difference is the radical is only over the 7x. It's not over the entire expression. So because of that, I have to treat this a bit different. We can't just cancel out the radicals and move on. We actually have to do what? We actually have to FOIL. We have to FOIL this out. When we FOIL this out, what happens? First, outer, inner, last. What's radical 7x times radical 7x?
7x.
It's just 7x. That's very good. And then we get what? Minus 3 rad 7x. That's the outer. The inner is going to be, again, minus 3 rad 7x. And then the last terms will be 9. What do you notice? Same terms. And so what do I get? I get 7x minus 6 rad 7x plus 9. So this is going to be placed in here. 7x minus 6 rad 7x plus 9. Then, don't forget, I got this negative 1 here that I have to distribute, and I'm left with 7x minus 6 rad 7x plus 9 minus 7x plus 3. That's what I have. And then what do? Minus 7x cancels out. I'm left with negative 6 rad 7x. And then the 9 and the 3 become 12. So this, I'm just going to rearrange it as 12 minus 6 rad 7x. And there you go. I have simplified the radical expressions in the beginning. And now I only have one radical. Any questions so far about simplifying? So we've done A, we've done B. Now buckle up your seatbelts for C. C is a doozy because you have a lot of radicals that you have to break down individually. So this is what we have. Look, we got x squared y square root of 20 x to the 5th y to the 7th minus 2x y square root 5x to the 7th y to the 7th plus 7x y squared rad 45 x to the 7th y to the x to the 7th y to the 5th. So this is what we got. 3 radicals. So it's a lot to deal with. So what I'm going to do is I'm going to break each of them down individually. So this is the first one, second one, and the third one. Okay, let's look at the first one. What is the first one? The square root of 20 x to the 5th y to the 7th. So let me break down each of them individually themselves. Rad 20, rad x to the 5th, again, it's multiplication, rad y to the 7th. Can I break down rad 20? How can I break down rad 20? How do you break down a radical, if possible? Anybody? Yeah.
4 times 5, and then you put 2 rad 5.
That's right. So this becomes 2 rad 5. Perfect. Very good. How about rad x to the 5th? How do you break down something that's not a number? It's a variable. It's a power of a variable. We still do the same idea. Find the largest perfect square that divides the number. So for example, in rad 20, the largest perfect square is 4. That divides 20. So 4 and 5, square root of 4 is 2. It's 2 rad 5. Now, when you have x to the 5th, that's a bit different, but the idea is still the same, right? What do I do? That's right, Ian. You do what? You rewrite this as x to the 4th. What's the largest perfect square that's a factor of x to the 5th? It's x to the 4th. It's 1 less. And you multiply that by just the leftover x. But what's the square root of x to the 4th? The reason why it's a perfect square is because the square root of x to the 4th is x squared rad x. So the square root of x to the 5th could be simplified to x squared rad x. How about y to the 7th? It's the same idea. Y to the 7th is what? Rad y to the 6th times rad y. What's the square root of y to the 6th? To y cubed. So this is what we got, guys. So this becomes what? What does this become? This becomes 2 rad 5 multiplied by x squared rad x multiplied by y cubed rad y. And then, what does this become now? You put all the terms that are outside a radical on the left. 2 is outside a radical. X squared is outside a radical. Y cubed is outside a radical. Put everything inside a radical within the radical. I got 5, I got x, and I got y. So that's number 1. All we did was number 1. Look at number 2. And it's going to go by very much the same way. I got rad 5, x to the 7th, y to the 7th. Break it up. Rad 5, rad x to the 7th, rad y to the 7th. Rad 5 can't break down. Leave as rad 5. X to the 7th, we just saw it, right? It's x to the 6 times x rad x, which is x cubed rad x. And then how about rad y? This is rad y to the 6 rad y. This is y second rad y. So what does this become? This becomes rad 5 x cubed rad x y squared rad y. And now I put everything that's outside the radical outside the radical. X cubed y squared, and everything inside the radical inside the radical. 5xy. So far, all I've done is break down the first radical, second radical, and simplified it as much as I can. Last one of the radicals to simplify is the third one. The third one looks like this: 45 x to the 7th.
Excuse me, Professor. Can you go
Yes.
up?
Yes.
Can you go up a bit?
Yes.
The rad y to the 7th power. Can you explain that back again? Isn't it supposed to be y to the 3rd power, rad y?
I just saw that. You're right. I saw that mistake as well. It's y cubed. You're right. This should be cubed. That's right. So when you take the square root of a power, you're halving it. So you're right. 6 divided by 2 is 3. So it should be y cubed. Very good. Thank you. Thank you. Thank you. Please, by all means, tell me, hey, Professor, you got this all wrong. I'll be like, what? I have no problem correcting it. No problem. Okay, good. And now I think now we kind of get the idea, right? Once we get to the third one, we kind of get the idea. So this should be what? Rad 9, rad 5. This should be what? Rad x to the 6, rad x. We saw this already. And then y to the 4th, y, right? And this becomes 3 rad 5. This becomes 6 divided by 2 is 3. So this is x cubed rad x. And then 4 divided by 2 is 2. So this is y squared rad y. So this equals 3 rad 5, x cubed rad x, y squared rad y. What does that equal? That becomes 3 x cubed y squared square root 5x y. So we got one radical broken down, two radicals broken down, three radicals broken down. And we didn't even really finish yet with this, because we have to go back to the original expression, right? And let me just put it here then. So the original expression is what? X squared y. Now what does this radical become? It becomes, let me just box these to make it easier to identify different radicals. So I simplified the first radical to 2x squared y cubed square root of 5xy minus 2xy, and then this becomes x cubed y cubed square root of 5xy again, plus, and then this becomes 3x cubed y squared. Sorry, this is 7xy squared, 3x cubed y squared square root of 5xy. So this is what I got. This is a mouthful, isn't it? So what I'm going to do is I'm going to take this, copy it, and put it here. We're almost there with this one. We're almost there, guys. We're almost done. So now from here, I need to multiply each of those groups of terms, right? So I need to multiply these two here, and I get what? I get 2x to the 4th, y to the 4th, square root of 5xy. What do I get here? I get minus 2x to the 4th, y to the 4th, square root of 5xy, plus this is 21, x to the 4th, y to the 4th, rad 5xy. But what's so convenient about this is that this here and this here cancel since it's the same one. They're the same terms. You're subtracting the same two terms. Cancel out. And so then what is my final answer? My final answer is 21 x to the fourth y to the fourth square root of 5x y. This one took a lot longer than the other ones. Of course, on the on the moment of the exam, we're not going to be taking this nice little pace that I'm taking, and we're not going to be probably not going to be breaking down each of these the same way, right? On the day of exam, you'll be doing it on the fly. You'll be thinking about, oh, how to do this on the fly as quickly as possible. Okay. Any questions about simplifying radicals? That's part C. It's a heavy duty one, right? It's a heavy duty question. Okay, that's part C. And now part D. Great, even more stuff. What we have here is a whole bunch of exponents. I got B, I got 3/2. This is raised to the -4. This is 8. This is A to the 6, B to the -9 squared. And all of this is being divided by A to the 4th, B to the 8 to the -1/2. Okay. This might be the last one. I don't know if it's going to take the whole time. But so we have a whole bunch of stuff here. We got negative exponents, we got fractional negative exponents, we got fractional exponents. All right. Now, where to begin? Where to start? This is really up to everyone's discretion. You don't have to start at a specific spot, specific place. As long as you make the right steps every time, you're okay. What I'm going to do is I'm going to realize, wait a minute, this 1/2 here, I can do the bottom, the denominator much quicker than anything else. Or I could take care of this negative exponent. So this becomes A to the 4th power. Okay, this is what I'm going to do. I'm going to break down each of these, okay? So I'm going to take this, call it 1. Take this, call it the second piece, third piece. And the third piece I'm going to do first. So what's the third piece say? A to the 4th, B to the 8th power. This is raised to the -1/2 power. I can write this as A to the 4th, raised to the -1/2 power, multiplied by B to the 8th, raised to the -1/2 power. When you have a power raised to a power, you multiply. This becomes A to the -2 because 4 divided times 1/2 is 4 divided by 2, which is 2. But it's a negative, so it's A -2. And then I got the same thing, B to the -4. So this is going to be A to the -2 times B to the -4. That's what the denominator simplifies to. The second piece is also not too bad because I got 8. I got A 6, B to the -9. I square it. So what I do is I take 8, square it. Take A to the 6, square that, and take B to the -9, square that. 8 squared is 64. 8A to the 6 squared is A to the 12 because I multiply the exponents. B to the -9 squared, it becomes B to the -18. So this here becomes 64, A to the 12, B to the -18. And then part 1, I got 2A to the -5, B to the 3/2, and this is to the raised to the -4. This might be the hardest one, quote unquote. What is this going to be? 2 to the -4, A to the -5th power to the -4th power multiplied by B to the 3/2 raised to the -4. What is 2 to the -4? That's 1 over 2 to the 4. A to the -5 to the -4, I multiply and I get A to the +20. B to the 3/2 to the -4 becomes B, and you multiply, right? This becomes -6. B to the -6. And 1 over 16 is going to, 1 over 2 to the 4th is 16. So I can write this as 1 over 16 times A to the 20th times B to the -6. And I can write that here. I can write that as 1 over 16 times a to the 20th times b to the negative 6. So I'm going to take this. I'm going to put it over here. Now, let's simplify. What can I simplify? The 16 and the 64, right, becomes a 4. So I have a 4 out here. Then what else can I simplify? The 8 to the 20th, the 8 to the 12th. What happens when I pair those up? 8 to the 20th times 8 to the 12, b to the negative 6 times b to the negative 18. And I got 8 to the negative 2 times b to the negative 4 in the denominator. Well, now, same base, multiplication, I add the exponent. So I got 4a to the 32nd power. Same thing happens here. Add the exponents. I got b to the negative 24. Divide all of that by a to the negative 2 times b to the negative 4. What I want to do is I want to rewrite everything with the same with positive exponents. So what can I do here? I subtract the exponents and I get 4a to the 34th power, because 32 minus negative 2 is 32 plus 2. And then what does this become? This is times b, negative 24. So when I subtract negative 24 minus negative 4, I get negative 24 plus 4. And this becomes negative 20th power. And I want negative exponents to be positive exponents. So this becomes 4a to the 34th power all over b to the 20th power. Woo! Woo, woo, woo. Packs a punch, doesn't it?